Hi everyone. In the previous videos, we have seen how to draw the voltage transfer characteristic curve of an operational amplifier and what are the modes of op amp, and also in detail we have seen what is the open loop mode of op amp. Now in this video we are going to see why the op amp in the open loop mode is not used for linear applications. As the definition itself indicates, the linear means the output should vary according to the change in input. So if there is a change in the input signal within the fraction of seconds, the circuit has to respond and has to produce the change at its output. If you observe the voltage transfer characteristic of op amp, if you consider IC741, the transfer characteristic will be look like this. Okay, if you clearly observe, with the minimum change in input voltage, at that time only the op amp is working in a linear mode. So minimum means which is in the order of microvolts. Okay, so within the microvolt signal itself, the op amp is operating in linear mode, but after that it becomes a saturation, which indicates that with the small input voltage itself drives the op amp to enter to saturation point. Okay, so we know that in the open loop mode the gain of an op amp is very high. Ideal case, if I consider, then it is infinite. So in the open loop mode, with the minimum change in input voltage, the output voltage is going to a saturation value, means some of the signal is clipped or some of the information will be lost. So this is the major drawback why the op amp in open loop mode is not used for linear applications, because whatever the input signals that are applying, that are will be in the range of millivolts or volts. Okay, so you have to use the op amp in for linear applications, and that too in the open loop mode. Then we have to make clear that the input voltages applied at the inputs of an operational amplifier should be in terms of microvolts. Then in that case only the op amp will work as a linear mode. Okay, now the other drawbacks why it is not used for linear application we are going to see now. So the first point itself we have deal, that is the open loop gain of op amp is very high. So a small input voltage will drive the op amp output voltage to the saturation level. This saturation level is nothing but a positive or negative voltage signal. So here in open loop configuration, the output may be at a positive saturation value or a negative saturation depending on the inputs applied, or depending on the sign of an input signal. That is for DC signals. For example, if you are considering a AC input signal, then this output voltage value will shifted from positive VSAT to a negative VSAT. So if you see how the graph of a output signal will look like, it will looks like this. Okay, so this is the input voltage. So within the linear mode, if the input voltage value is within the linear values, then the output signal will be a perfect signal, means with no information loss. If the input signal will exceeds the boundary values of a differential voltage, then the output signal is some distorted signal will get, means here some information will be lost. So here this ability of an op amp is nothing but for a microvolt input signal. In that case only the op amp in open loop mode will be suitable for linear applications. Greater than a microvolt signal, that is in the range of millivolts or volt signal, then the op amp in open loop mode is not suitable for linear applications. So this is the reason why we are not using the open loop op amp in linear applications. Thank you.